Yeah, I have gone through NLP and LLMs. First of all, NLP is a subfield of AI which focuses on the interaction between the humans and the computer's language. It also combines computer science and machine learning to enable machines and to read, interpret, and generate human languages. Whereas there is also text classification, which assigning categories to text such as a spam detection and sentiment analysis, which determine the emotion tone behind a body of text. And we also have a mission translation, which automatically translate the text from one language to another, and the name entity recognition, which identifies and classifies the element in text into predefined categories. There is also speech recognition, which converts the spoken language into the text. These tasks are achieved through various techniques and including rule-based approaches and machine learning algorithms. Whereas coming to LLM are a subset of NLP model characterized by their large size and capability to process and generate human-like text. They are also trained on vast amounts of data and utilize deep learning architectures, particularly transformer models, to understand context and generate coherent responses. Whereas key features of LLM includes contextual understanding, which ability to grab the context of a conversation or text. There is also a text generator which produces human-like text based on prompts which we give. And the LLMs also revolutionized the field of NLP by enabling more natural and dynamic interaction between the humans and machines. Whereas now coming to the transformer is a model which is designed to handle uh, sequential data such as text by leveraging mechanism called self-attention. This also allows the model to weigh the importance of different words in the sentence, regulating the position, enabling it to capture long-range dependencies and the contextual relationship more effectively. There also the transformer consists of encoder and the decoder. Okay, then we also have the word embeddings, which are the fundamental concept in LLM and natural language processing. This learning model does not understand the text, it understands the numbers. So we need to represent the text as a number. As when we are building a language model, we have to represent a word, okay? And the transformer architecture, where I told that there is an encoder and the decoder. The first of all, the purpose of the encoder is to take the input sentences and generate the contextual embedding for each of the words or each of the tokens in the sentence, which have taken. Once the contextual embedding is generated, we feed that to the decoder. Okay, here we try to predict the next word so that we are working on the next prediction. In this generic architecture for transform model is a concept, whereas we have know that for Google there is a bird and the GPT are the specific models with specific architecture. If we are looking at the bird architecture, it has only the encoder part. Okay, if we are taking as a GPT, this it has only the decoder. So it still takes the input, it will produce the contextual embedding and so on. And there here it will predict the next word. I mean, it sounds like it has an encoder, decoder, but both the fundamentally the architecture looks like different for the GPT, but it is still based on the transformer architecture only. Okay, and we can see that the decoder is not going to take much time. So let's understand the decoder. is, and the output of the encoder is a contextual embedding, and the contextual rich embedding which we give it to as an input for the decoder. Okay, and it will produce the next word prediction if the language translated will start with the specific token called start, and that they will produce it. Okay, this is about the transformers and that encoder and decoder and the word embedding. Okay.